Hey everyone, I think we're going to get started. Welcome to our nth Midas session on GenAI tools. I'm really delighted and so pleased to be able to welcome Juan Gutiérrez today to talk about farm-to-table GenAI. Juan is a professor of mathematics at UTSA, and his research applies data science tools to problems in biology and social science. I would really encourage everyone here to visit his website because his website is incredible. He's a musician. He wrote fiction before he became a professor, and just a really lovely and interesting guy. He even has like really good answers to hard questions that graduate students have about grad school. Like, should I do this at all? And I asked him how to describe what he's been doing these days, and he said that what he really wanted me to say was just a single sentence, which is that his work aims to use tools from data science to have the face of success match the face of society. And I will welcome him. Thank you so much.
Thank you very much. Hello, everybody. Crowd. I was actually expecting a much smaller crowd because, this is hard. What we will do today is very hard. We have how many hours? 8? 12? Normally, this activity is done in an event called the Rowdy Datathon. This is a data competition open to undergraduate and graduate students at the University of Texas in San Antonio. And we give them 24 hours, on site. We feed them, we throw sleeping bags, and they come. And in 24 hours, they have to solve a very hard problem. Until last year, it was impossible to do it. And last year, for the first time, we have students finishing because they use generative AI. So we have learned quite a few tricks about how to deploy these tools, how to make them work for you, how to accomplish stuff that it was just impossible in terms of productivity, the speed at which you can gain understanding, you can produce solutions that can be deployed in research so you can win the next grants and bring the bacon home and all the good things that come with those sources of funding. So today, I'm going to spend about 20 minutes introducing the problem, and you're going to have, if I'm correct, 2 hours maybe to finish it or something like that. You can stop whenever you want. I'm going to give you a few tools, but I want to show you that it is possible to tackle very hard questions. And I don't mean technically hard. I mean societally hard questions, and do it effectively at record speed. So let's begin. If you ask people what is artificial intelligence, and I'm going to turn my microphone on so I can walk and you can hear. There you go now. Artificial intelligence. You ask many people, you have many definitions. So the first thing that I'm going to do is just go to the etymological sense of what artificial intelligence is. So it comes from Latin, artificium, handicraft, artificialis is just artificial. Inter, between, legere, choose, interlegere. Intelligere, choose in between, intelligere, understand, intelligentsia, intelligence. So artificial intelligence is just manufactured understanding. And no time before 2023, it was so clear that this is perhaps the best description that we have for artificial intelligence in this moment. Until very recently, the only way to access AI tools was through coding. So please, a show of hands, how many of you are uncomfortable? No, I'm going to say uncomfortable coding now. How many of you are comfortable coding? Okay, I would say half and half. Very good. So what happens is large language models lower the barriers to access artificial intelligence. How? We will see in just a moment. So you don't have to code anymore. Well, actually, that's not true. You need to code a little bit. The advantage that you have is that if you don't know how to code something, you can ask an AI agent to begin for you. You still need to be able to read what the agent is producing. So there is a paper, Attention is All You Need, 2017, and this is the foundation of what transformers are. Attention is all you need because there is a component of attention that goes with trying to understand the sense in a context. So this self-attention mechanism can be computed, it's just a metric. And this is very advantageous to understand sense in language. So you might have heard the word token when you measure the complexity of the interaction with an AI agent in a large language model. A token is a unit that gives meaning. For example, a word is considered one token. This is important because if you open the API, the application programming interface, then it's going to charge you $30 for 1 million tokens. 1 million words? Well, not words, because a period makes sense in a sentence. An exclamation sign, a question mark. So everything that gives meaning to a sentence is considered a token. And now what we can do is interact with an AI agent. What I have here, this is an actual task used for operations of a math department. We had one file, and this file had scheduled credit hours in one tab, and then in other tab we had other information regarding to fees. So we wanted to know how much money were we collecting by fees, and if you have to program it with Python, actually this couldn't be done in Excel quickly, the complexity and the structure of the files. So it had to be done with Python. I looked at the task, oh my God, 1 day lost. What if we use this? And it took 20 minutes to produce the response that we were looking for. So when you use a transformer like ChatGPT, probably you have used ChatGPT, I'm going to guess. Raise your hand if you have used ChatGPT before. Good, excellent. You might have noticed something. If you're trying to solve a complex problem, ChatGPT will forget what you told in the beginning. And eventually, if you do it with long enough interactions, you will notice that information will drop off the window. Why? Because there is limited memory span. That if you use GPT-4 Turbo, it's a very large window. You can essentially introduce a novel into the system and it still will remember. But what if you start using complex documents, data dictionaries, documentation? You will reach the window. If you're solving a practical problem, you will reach the window. We don't have, with GPT, even 4 Turbo, unlimited memory. So this is a real problem. And of course, this is due to the limit in memory that we have. How do we eliminate or minimize memory spans? You want to identify the things that are useful in an exchange, because not everything is useful in an exchange. If you have used ChatGPT long enough, you will notice immediately that some answers are very good, some answers are terrible. And as you keep accumulating, where are the good answers? Where did they go? Are they lost? You want to keep an index for them. And you want to give directives. So in ChatGPT, there is an area at the bottom left where you can introduce your custom directives. I'm going to give you my directives for ChatGPT. The text is a little bit small because I have several, but I'm going to read the essence for you. When you give these custom directives, every interaction that you have is shaped by these directives because they don't drop off memory. They remain in the memory window. That's why they're so important. It doesn't matter how long the exchange is, this will remain in memory. So I tell directive R1, it's important that you give a moniker, a name to your directive. It's a directive R1, unless I request otherwise, I need detailed answers without adjectives. Right? Because I'm a scientist. I don't need to know that something is big or small. I just need the quantifier. Directive R2, I need answers in paragraphs instead of lists. You might have noticed that ChatGPT tends to give you bullet points. And if you're trying to get text, that's very inconvenient. That's not what you might want in some cases. I need responses with references. Never, ever generate references. Use only existing references for which there is a URL. If referencing a book, indicate the page number for the citation. Does not always work. You still have to check it. But by giving this directive, it minimizes the phenomenon of generated references. A large language model generates content. It's generative AI. So if you ask for references, it's a machine. It's going to ask It's going to answer whatever you asked. So of course it's going to give you references. Are they real? They might not be real. So this directive is very important in practice. R4 is for Jupyter Markdown. Sometimes I request code and the format is not very convenient, so I just tell it, give me clean code. Directive R5, do not generate text with participial phrases. This is the signature of ChatGPT, is one of the signatures of the system. It's very easy to check whether something has been produced with ChatGPT raw without these directives. If it has a ton of participial phrases, if you don't know what they are, ask GPT to explain, and then you can gain understanding. Directive R6, I give ChatGPT a collection, an example of my writing. Say, this is how I write. I need you to emulate the way I write in the number of adjectives, in the length of sentences, and so on. And it will do a decent job emulating my writing. So the point is, and by the way, these slides are going to be available for everybody, so don't feel that you have to take notes or take pictures. You have it. Everything I have, I share, no limit. You have everything. These are important. Now you have rails, and those rails will help you reach your destination. If you drive ChatGPT without rails, it's like jumping in a turbocharged sports car, not knowing how to drive. How do you think that will end? It's not going to end well. The same way that we're giving kids in high school and elementary school and middle school the keys to this instrument. Go, drive. They're going to crash. So we have to build the rails for everybody. So every time that I start a chat, I start with the confirmation that it knows my directives. Why? Because I have a dictionary of directives. In a Word document, I just put aside, depending on what I'm doing, I use the directives for the task. So therefore, I need to know, what am I using in this moment? Echo back. It will echo back. It's not literal. It's going to summarize what the directives are. Then, when you interact, you have to tell it, this is wrong. And you can use the keywords, put it in memory. If you have a fact that you want to correct, just try it. Just put it in memory, and an icon will show it's in memory now. It will remember for the duration of the interaction, like a directive that you can add. But you have to explain and be factual. It will make a relatively good job. It will do a good job avoiding the same mistake if you tell it that it was a mistake and the reason why it was a mistake. Now, this is what I have found most useful in very long exchanges. And when I say long exchanges, I mean hundreds, sometimes thousands of interactions in a chat, some of which are programmatic. I don't enter everything by hand. If it gives you a useful answer, instruct, define the previous answer as number, you name it whatever you want. Bold 1 or answer A1, doesn't matter. Just keep a tab of what you're indexing. Why? Because as you interact, you might be able to cross-reference previous useful answers. So you can say, use answer A1 and B3 into a single paragraph and enforce directive 4. And it will produce something that is conforming to what you really want. But how do you know that this is what you really want? Because you took the time in defining what the directives are, building the tracks so you can transit this landscape. Okay, what type of problems can this tackle? So please understand, and I'm sure you do, ChatGPT will not make a genius out of you. No large language model will. You cannot outsource genius. It will accelerate the process to put in your hands the answers that are within your reach. So if you have the knowledge to ask the right questions, you might get a useful answer. But if you're trying to reach an answer and you don't know how to reach that spot, you will never find something useful. It's not going to happen. You might be able to build the knowledge to reach the point in which you can ask, important questions. And I'm going to give you an example of a homework that we give students in which unless they truly know the subject, ChatGPT will help in nothing. It's going to be a failure. And it's a beautiful example of how this technology works. So this is the example. This is a real homework. This is the first homework in data analytics, mathematical foundations of data analytics, the class that I teach once a year. So a quiz for everybody. Quiz on the spot, math quiz. What is the answer to this question? 1 minus 1/3 minus 2/3. What is the answer?
0.
It's not 0. Okay, so what about 1 minus 2/3 minus 1/3? No, it's a different answer. Addition is not commutative in floating point. You can test it yourselves in your computer. If you have Python installed, just type Python, then you get the prompt, and then you type 1 minus 1/3 minus 2/3, you will find this answer. And it's very important to understand why. If you understand why, then you understand how computers work. And if you understand how computers work, then you can use them as effective tools. Oh, the next answer, 10 to the 20 plus 1 minus 10 to the 20. Of course, you saw the answer. I flashed it accidentally. But let's say that you forget that you saw it. What is it? Should be. Give me something. 10 to the 20 plus 1 minus 10 to the 20. Should be 1, right? But it's not. It's 0. And 10 to the 10 plus 1 minus 10 to the 10. It should be? And this one is 1. Now, why? If you just ask ChatGPT, and this is the homework for the students, ask ChatGPT to explain this. And I tell them in the class, but first you have to read the chapter where the theory is about floating point arithmetic. How many students do you think read the chapter in floating point arithmetic before attempting this? Nobody does, and they crash, because this cannot be answered by ChatGPT or any large language model that I know of in this moment. And I have tested a few, but they're becoming better, so maybe in the future this will be obsolete, what I'm just saying. But I suspect it's going to be valid still. It cannot do it because you have to ask something very specific to provide an answer. If you ask ChatGPT, produce a computer program and explain to me why it is 1.1102 exponent minus 16 when I do that operation, it will not be able to do it. You have to ask something different. Now, we can bypass this. I'm just going to accelerate, try to finish in the next 10 minutes or less. So we can jump into the data problem. Wicked problem. So wicked problems, complex solution with an unknown number of potential solutions. What is a wicked problem? Well, problem is never completely solved. And the best hope is to try to improve a previous state. An attained problem is when there is a clear solution. The solution might come from past knowledge, and everybody agrees what the solution is and what the best state is. Can you think of an example of a attained problem? What is a attained problem? Something that can be solved. Let's say build an elevator for a building. Has been done. We know how to do it. Attained problem. Done. We can even estimate the cost. How about eliminating poverty? What does that even mean? How do we know that we have reached the end? It's just comparative. It's with respect to the previous state. So the nature of a wicked problem solution, there is no stopping rule. The solution is neither true or false, and you might never know whether this solution is the best. This is kind of important when you attack a problem and you try to release the power of generative AI or artificial intelligence in general. What type of answers can you reach? We can bypass this. And a show of hands. Can generative AI tackle wicked problems? How many say yes?
Directly or indirectly?
Just, yeah, okay. We have 2, 3, 4, 5, 6, 7. Okay, I would say half. And 10 problems. I was expecting to see many more. Okay, but that's fine. So the other half. So if you haven't thought about it, just think about it. It's an interesting question. What type of questions can you answer? And I think that both are answerable. They just require very different approaches and understanding of what the tool is, the reach of the tool, and how to drive this. The case of Abraham Wald. So let me just zoom in here. And how many of you have seen this before? Half. Okay. Those of you who have not seen it, I'm going to tell you the story, what it is. In World War II, a fellow mathematician, Abraham Wald, was tasked with coming up with the optimal place to reinforce planes. They were coming from missions, and he never drew this plane. This was reconstructed from the notes that he had. So if somebody asks you, we have to put steel plates in the plane, where do you put them? Those of you who know already, zip it. Where should we put the reinforcement? Anybody?
Leading edge of the wing.
At the edge of the wing, like in these areas?
Leading edge. Where most of the lift.
Here?
Probably a little closer.
Or here?
No, I mean the leading edge.
Oh, yeah, and why is that?
I mean, what's needed to generate lift.
Very good, that's a good reason. Somebody else? In the cockpit? Yes, that's what a General Guy Walsh, fighter jet pilot, told me once. He asked, do you know when a jet fighter pilot is in the room? I don't know, how? Because he will tell you. So he told me. And he said, yeah, you have to protect the pilot. That's good. So what Abraham Wald concluded is that we should put the reinforcement where the holes are not, because those are the places that never came back. So many times, the most important information is in the data gap. And sometimes the most important phenomenon, the driving phenomenon, is what we cannot see, what we cannot measure. So we have a problem here because generative AI and artificial intelligence can only deal with digitized information. But what if we have bias in the information and the data that we have? What problem are we going to solve? So understanding the bias and the context of data becomes important. And of course, right now we're living a Gutenberg moment. This has changed the way we do everything from now on. And 2023 will be remembered as the year it happened. But AI can only respond to this digitized information. I'm going to bypass all this because I don't want to stay here for too long. This is very interesting. I hope that you have the chance to read some of this. The slides are there. You can use them. But I'm going to tell you something about the data that we will, I'm sorry, did I hear some? Oh no, I thought I heard somebody talking. I'm going to tell you something about the data challenge we're going to try to solve today. So this is the city of San Antonio, where I come from, San Antonio, Texas. On the left, there is the Opportunity Atlas. Greenish and bluish means high income. Reddish means low income. So of course, you want to be in the greenish areas. On this side are the school districts of the city. And the percentages I'm going to show you, that they will show up here, is the percentages of kids taking Algebra 2 in high school. How many of you took Algebra 2 in high school? So, okay. Did somebody here not take Algebra 2 in high school? You never took Algebra 2 in high school? Okay, good. It normally people, well, not normally. The majority of students take Algebra 2 in Michigan. That's what they're thinking. But in 2013, the Texas legislation passed a law saying We don't need Algebra 2 because not everybody needs a college degree, which sounds reasonable. Yeah, somebody has to sweep the streets. Somebody has to flip burgers. The problem is who? Who are we setting up to do that? 17%, that means of the entire school district, 17% of the kids take Algebra 2, which is a very high number. This is not only high school or senior year. And this is one of the wealthiest zip codes in the United States, Alamo Heights. Then Schertz, another affluent area. And then this is Bernie, Northeast, La Vernia, there is oil there. This is one of the Army bases. And then suddenly it starts dropping, and the percentage is going to start matching the red color that you see there until reaching 2% in Floresville, which is south of South San Antonio Independent School District. The city has like 19 independent school districts, and this was because some parts of the city didn't want to share their tax dollars, so they declared independence. And said, Alamo Heights is a city, inside the city. Why? Because they said, we want our dollars here. I don't want to send my dollars to Southside. And this is a problem. On the x-axis, and this is the first exercise that you guys are going to do, reproduce this plot. A student population by a school district. Each dot is a school district. On the y-axis, Algebra 2 enrollees. If you do naive data analysis of the type that you should never do, you would reach the conclusion everything is fine. Because this simply shows that the more students you have, the more Algebra 2 enrollees there are. So everything is fine, except when you look at poverty. Now the x-axis is students in poverty in every school district. And the y-axis is Algebra 2 enrollees. This line, which is the 45-degree angle, I mean, this is not 45 degrees because the axes are not equally spaced. It means that the dots above the line, this group here, are the school districts in which there are more kids taking Algebra 2 than kids in poverty. And the other school districts, there are more kids in poverty than kids taking Algebra 2. This is a problem because of this. On this side, donors, and these are acceptors. We're at a university. You have seen many undergraduate students. They come and say, I'm a pre-med. How many make it to medical school? Or they say, I'm an engineer. How make it graduate as engineers? Turns out that if you're a university college and declare majors, you distribute yourself across the university. But if you're in biology, you go to kinesiology, sociology, and psychology, even though you were a pre-med. And the largest correlation is failing the first year core curriculum math class. And who is well positioned to pass that class? Those kids who took Algebra 2. And who is taking Algebra 2? Those school districts that are most affluent across the entire United States. So zip code is destiny. If you think that there is no royalty in the US, you're wrong. There is royalty. And we all play in that game. And what happens is, who gets a doctoral degree or a graduate degree? Those who graduated in the field. So if our students are failing out of STEM because of their poor preparation in elementary school and middle school and high school, and they don't graduate from STEM, of course, those PhDs will not show up. And we can measure this with the survey of earned doctorates from the National Science Foundation, in which we can compute the ratios between, in this case, because I'm in a Hispanic serving institution, I did the statistic for Hispanic students versus non-Hispanic. And what happens is the lower the ratio, the more parity there is. That is, there is the same proportion of individuals from one group compared to the other taking these studies, which are psychology, education, area studies, and foreign language. A greater number would mean there is large disparity. And this disparity is mathematics, business administration, and computer science. Do you see a pattern there? Because if you now look at the ethnic and racial composition of those fields, there is a bias. And we can pinpoint where the bias begins. It's the investments that we're doing as a society. You have the data in your hands today to look at this. And it would have taken a full year to do the analysis. As you will see, you will be able to finish it in 1 hour. Well, maybe. You have more time if you want. You can go home and keep working on it. But my goal today is to allow you to go after this. So this is the data challenge. You are congressional interns. Undergraduate students love this. Say, oh my God, I'm going to work for fill the blank. And then you have to come up with a strategy to allocate funds. Determine the socioeconomic and or environmental factors that influence educational attainment. How to allocate resources based on the need to address the most significant effectors identified. So you need to know what is driving this. And this congressperson works in a district in fill the blank, Michigan, Texas, any part of the US, because we have national data. And we have very complex data sets, millions of records. We're going to do the analysis with generative AI. Now, I would like to call your attention to something, and let me go back. Perhaps I put it here. No, I don't have the slide in this presentation. Think about the following. If a person with a bachelor's degree over a lifetime makes well over $1 million compared to a person with without a bachelor's degree, and this is lifetime, and the average graduation rate in public institutions in the US is, do you know what that is? Throw a number. What do you think is the average graduation rate in US colleges and universities? Throw any number.
60%. 30.
Like 50. It's half. Half never graduate. So let's say it's 50. So what was the size of the incoming class in this institution? Or what is going to be for the fall semester? I'm going to guess maybe 6,000 students? Well, let's say 6,000. Maybe it's more, I don't know. I don't know how many students do you have here. But let's say 6,000. And let's assume this is the average American university. It's not, but let's assume for a moment, just for the sake of the argument. So 3,000 students would never graduate, right? Now, you can do math. What is 3,000 times 1 million? That would be, you don't need generative AI to answer that. Come on. $3 billion removed from the regional economy in 1 year in terms of lifetime earnings. People who never complete college are saddled with debt. So not only we are binding that person to poverty, their children as well. Now multiply that by all the universities across the nation. It's hundreds of billions of dollars every year. It's a multi-trillion-dollar problem every decade of wealth that is not generated. And this lack of generation is concentrated along ethnic and racial lines. Why? Because that's the investment that we made at the education level in K through 12. It's a big problem. So let's tackle it now.